Welcome back. In this video, we're going to continue that conversation of what do we do with elimination when it's not just like, oh, I can just, cancel here, or I can subtract or add here. So are the equations lined up is always the first step. I have 3x over 5x, that's fine. 3y over 4y, that's fine. Equals over equals, and constant over constant. We are lined up. So then I'm going to look for common coefficients. I look at my x. Can my x's cancel? I got a 3 and a 5. Yeah, they're not going to eliminate with the 3 and a 5. And multiplying the 3 times a 5, not really a good option either. Or multiplying by 3 times a number to get to 5 is not an option. What about 3 to 4? Yep, that doesn't really look like it's going to work either. So in this case, what we want to do is we want to think about numbers that we can use to multiply, that we can make both equations be what we want it to be. So for instance, if I was looking at the x term, I'm like, okay, I want these x's to cancel. I want them to eliminate by having additive inverses, meaning that when I add the coefficients together, they are going to add to 0 or subtract to 0. So what can I multiply the 3 by, and what can I multiply the 5 by to get numbers that would be the same? Well, you could actually just multiply by 5 here, that'd be 15, and by 3 here, that would be 15. Then I stop and think real quick, 15 and 15, remember I want one of these to cancel, so I want one of them to be negative. Does it matter which one? No, your choice. I'm just going to pick the second one. And then I'm going to distribute. Let's start with the top equation. I'm going to distribute that 5. So now I have 15x plus 15y equals 45. On my second equation, I have negative 15x minus 12y equals negative 30. Be careful with that negative. Make sure it gets all the way through. I can combine 15x and negative 15x. Well, that is a 0, so we can say that we can go ahead and cancel that out. 15y and negative 12y is 3y. Bring down the equals. 45 minus 30, 15. We're going to divide both sides by 3 because remember we eliminated x, so now we're just solving for y. So y equals 5. And then we take that y value and we plug it back in. Does it matter which one? Nope. I'm just going to use the first one. It says 3x plus 3y equals 9. I know y, so I'm going to plug it in. So 3x plus 3 times 5 equals 9. That would be 3x plus 15 equals 9. I'm going to subtract that 15 from both sides. Now 3x is going to equal negative 6. Don't forget now we divide by 2 or by 3 on both sides. That's trying to divide first. So x equals negative divided by a positive is still negative, and 6 divided by 3 is 2. So my solution looks like negative 2, 5. Now remember, go back and check it. Make sure that when you multiply that back out in both equations, it's true for both sets. All right, I want to look at this exact same problem again. I think, what if I don't want to cancel the x? What if I want to cancel the y? I have a 3 and a 4. 3 will not multiply to 4 nicely, and 4 definitely won't get to 3 nicely. But I could multiply 3 times 4 or 4 times 3 and have a 12y to 12y. So when we think about changing, it doesn't matter if we change the x or the y. It's completely your choice. You're the mathematician. I do know, though, that these are both positive, and I need one of them to be negative. So does it matter which one? Absolutely not. But make sure that if you're trying to change and make it to where they're going to cancel or they're going to add to 0, that you are thinking about that. So 12x plus 12y equals 36. And negative 15x minus 12y equals negative 30. From here, we just combine 12x and negative 15x. That would be negative 3x. Remember the 12s? That's what we were, as mathematicians, setting up to eliminate. And 36 minus 30 would be 6. We're going to divide both sides by negative 3. And here we have the x first. We had negative 2. So when you plug it back in, instead of plugging it in for the y, you would plug it in for the x. I put it right here. So that'd be 3 times negative 2 plus 3y equals 9. Or negative 6 plus 3y equals 9. add that 6 to both sides, and I have 3y equals 15. We can divide both sides by 3. I'm going to get y equals 5. So my solution, x then y, negative 2, 5. And then I can plug this back in. Now, again, that looks just like the same solution we had when we multiplied to eliminate the x. As mathematicians, you're going to have to make decisions. What do I want to eliminate, and how can I do so?